All right, looking at number 3 in 8.6, graphing linear inequalities. Um, what I did on this problem was I looked at the inequality here, and then I decided to put it into Desmos to see what it looks like. Um, and what we see here is that we get uh, this vertical line right through 6, and then we end up shading the right side of that line, and it's a solid line. Okay, so let's go back to the worksheet or the note packet and take a look at how we would end up with that. Okay, now first of all, it does say use the 2-point method. Well, when looking through this, I could just go ahead and try the intercept method. But if I do a little upfront work and I think, hey, wow, something looks a little weird here. This matches this. Now, with a little practice, you'll know that you can just cancel those out. But if you're saying, well, I'm going to get my y's on one side and my x's on the other side, if you're using kind of that old school canceling math, we'd add 5y to both sides, and we get 7x is greater than or equal to 42. Now that looks similar to something that we saw earlier this chapter where we notice, hey, there's no y value present, so I'm going to isolate x, and I come up with x is greater than or equal to 6. Now what we think about is to graph our boundary line, we think about x equals 6. Okay? And if we're looking for 2 points, we know that x is 6, and then we can pick the y value. So I'm just going to pick 0 and 2. So if I go over to 6 here and plot 6, 0 and 6, 2, they're stacked right on top of each other. And I know it's going to be a vertical line. I know it's going to be a solid line because I see the equal sign involved. Okay, so there's my solid line. Okay, and if I test the point 0, 0, what I find out is the only place I can put 0 in is for x. I get 0 is greater than or equal to 6. This is my test. Testing 0, 0. This is false, all right? And therefore, I don't shade this side. I end up shading this side of the line, okay? So we see that we come up with the same thing that we got in Desmos, all right? So let's go on and look at the last one in 8.6 here. You're gonna probably get a problem that involves a fraction. Okay. Now there's a technique of that we could use to remove fractions. We wouldn't have to remove fractions, but I'm going to show you the technique of removing fractions here. I multiply both sides by 20. I get 4x plus 5y is greater than 20. Now I know right away it's going to be a dashed line because there's no equal sign in there. And then if I've been working hard in this chapter and kind of practicing, it might realize here that I'll try the intercept method because it says using 2 points. Okay, so if I put 0 in for x, cover that up with my finger, it says 5y equals 20. Remember, we use the equal sign when we're trying to find the point or the boundary. So we get y equals 4. Okay, that's a point, 0, 4. Okay? 0, 4 is right here. Okay, and then I'm going to put 0 in for y. I can cover this y term up with my finger. I get 4x equals 20. Divide by 4, x equals 5. All right, so 5, 0 is a point. I always have to take a little bit more time when thinking about plotting coordinates that have a 0 in there. Just take your time on those. And then so I get a dashed line through there. And I'll try to line that up. Well, I'm not going to show you this one in Desmos. You could type this in. Just trying to keep the video a little shorter. Okay, I get the dashed line. and then I'm going to test 0, 0. Okay? Now, if your line happened to go right through 0, 0, your boundary line, you would have to test a different point, like 5, 5, or 1, 1. You have to pick a point that's not on the boundary line. Okay, so I'm going to test 0, 0 back into the original inequality. And what I get is 4 times 0 plus 5 times 0 over 20 is greater than 1. What that leads me to is 0 over 20 is greater than 1. 0 is greater than 1. That's false. We didn't get any true ones here, okay? But if you did get true, you would shade that side. But this side is false. That means this side is true, and we only have one side that's true, so we would shade this side. Okay? All right, I hope that helps with graphing linear inequalities. This technique is going to be used in the end of Module 9 also, and we're going to graph two linear inequalities at the same time. Okay. Well, that wraps up 8.6. Thanks.